Students, we were discussing the purely inductive circuit and we have derived the equation for the current. Okay, the final expression for the current that I've written on top, that is I will be equal to I naught sine within bracket omega t minus 90 degree, since the voltage and the current are having a phase difference theta, and here your theta's value is 90 degree. Okay, and since you can see that there are two expressions I and the I naught, your I naught's value is V naught by omega L, which is what? Which is the peak value of the current, is I naught. Okay, so students, if you just previously recall the two equations that we have studied, I'm writing it once again, the two equations. The first equation was your V equation for V equals to V naught sine omega t. This is your equation 1. And what was your, yes, the final expression, that is this one. This is your equation number 3. Okay, so using these two equations, okay, we can see that we can come to the conclusions that the current lags behind the voltage by 90 degree. Okay, so students, I will just do graphical representations to show you that how the current is lagging behind the voltage by 90 degree. Okay, so these are your axes. So this graph that is represented by dash is your I naught sine omega t minus 90 degree, and the one that is marked by bold black lines, it is your V naught sine omega t. Okay, this is this particular y-axis may be your V or I. Okay, and this is your x-axis is with respect to omega t. All right, so we can see that the current is lagging behind the voltage by 90 degree. Okay, this is your pi, this part is your 2 pi. Okay, this part. Okay, here just whatever that I have put it in the graph, that I'm doing it in a short manner, showing that it is differing by 90 degree, that the current is lagging behind the voltage by 90 degree. This is your, as usually, the I part. Okay, this is your main graph. Okay, so students, the second part that we come after deriving the equations, that the quantity omega L plays the same role in an inductive circuit as the resistance R in a resistive circuit. The part omega L. Okay, so this quantity is known as the inductive reactance of an AC circuit, this omega L part. Understood? So this inductive reactance is the opposition offered by an inductor to the flow of alternating current through it. So just recall, recall the case of the purely resistive circuit, and now come to the case of this purely inductive circuit. So you can see, students, that both omega L and R, as I've said just now, that they are more or less play the same role, but the omega L term should be there and the omega L concept should be there in the case of the inductive circuit. So like the definition that we have studied from the junior classes, that the resistance opposes the flow of the current. Here and here the omega L is the opposition, that means this is the inductive reactance playing the same role like the resistor is the opposition that is being offered by this inductor L to the flow of alternating current through it. and it is denoted by the symbol this. Okay. So XL equals to omega L that we have seen is the inductive reactance, and its unit is also same like the ohm. Okay, like the resistor. Okay. Now we will see the power in the particular inductive circuit. So students, the phase difference between the voltage and the current is equal to 90 degree. Okay. So I'm writing here, students, the power, calculation of the power in the inductive circuit. If theta is equals to 90 degree, then what will be the value for the cos theta, that is your power factor? Cos theta will be equal to 0. Okay. So therefore the power consumption, okay, just recall the power and the power factor. So the power consumption will be what? Let's write the formula for the power. It's P equal to half V naught I naught cos theta is equal to 0 because your cos theta part is 0. So full thing will get 0. So the current in this particular inductive circuit is completely waterless. Understood? Okay, good. Now students, till now we have covered the purely inductive circuit, the power also we have done. Now let's move on to the purely capacitive circuit. Okay. Now students, I will just do the circuit diagram for the purely capacitive circuit. Circuit I'm writing in short, but in your exam write the full thing. Your current is flowing, see the direction of the arrow. Okay. Now students, this is the circuit diagram for the purely capacitive circuit. Now same way like the thing that we have proceeded for the purely inductive circuit, here also will proceed in the same way. That is, the alternating voltage that is being applied to the to this circuit is the same equation. I'm writing it here, that is V equals to V naught sine omega t. Alright, so at any moment, if Q be the charge that is being stored in the capacitor C, then its terminal potential difference is Q by C. Okay, that is the charge is equal to Q by C.